Hi, everyone. Thank you for joining ITTStar's Immersion Day. We'll be discussing how AI ML is changing the way companies work and take a deeper look into how leveraging image recognition software with AWS can enhance customer experience and business growth. So, our speakers today are John Aguilar, our Cloud Sales Manager, who's an expert in understanding customer needs and how businesses can integrate technology and provide the best possible cloud solutions for their needs. Next, we have Shubham Singhania, our marketing research analyst with technical skills. He strives to craft innovative solutions that can help drive businesses forward. Then finally, we have Nitin Das, our ML engineer. He's mastered the skill of AI ML over the years, and today we'll witness a product that his team has developed with his deep understanding of the AI ML world. Here's a quick overview of our session. So John will get us started with a brief introduction on ITTStar. Then Shubham will walk us through some common business problem statements and use cases where these services can be implemented for your business growth. Then finally, Nitin will walk us through a real-time demo with the AWS services used to develop a product for luxury goods. Then finally, we'll have a short Q&A session, so feel free to send any questions that you have in the Q&A chat. So let's get this started. I'll hand this over to John.
Thanks, Sanjana. Everyone, nice to meet you all. Thank you all for attending. My name is John Aguilar. Like she said, I'm our sales manager here at ITTStar, and looking forward to telling you a little bit more about what we do, who we are, where we come from, and what we're going to be talking about today. Shubham and Nitin are going to cover the majority of the technological aspects of today, but I wanted to get us started by giving you an overview of everything that ITTStar does, how we got started. And trust me, I won't take up too much of the time in today's agenda because I know exactly why you're all here, right? For the good stuff. So a little bit about ITTStar. This is kind of our global capacity and delivery capabilities. Our headquarters is here in Atlanta, Georgia, where myself and the remainder of our leadership team are, as well as other marketing, sales, administrative, and some of our delivery leads as well. Our West Coast office is over in Phoenix, with about 70% of our folks residing in our development center in Bangalore, India. We do have some folks in Mexico and London as well, and scattered around the US from remote workstations as well. But you can see a little bit of our numbers down below and our areas of expertise here on the right. The majority of what we're going to be talking about today comes from our data analytics team and that engine, but we do have other areas of expertise such as infrastructure and application migrations, business intelligence and analytics, our DevSecOps team that's doing some pretty exciting stuff when it comes to the cutting edge of what it means to incorporate security within the DevOps practice, right? And our 24/7 managed services team that covers the globe, right? To offer our customers an abundance of different services from a day-to-day 24/7 capacity. A little bit more about us and diving into some of the other practice areas and solutions that we have. We are a data analytics focused advanced consulting partner with AWS. And when it comes to AWS, that's where we're going all in on, right? We believe that AWS is the future of cloud technology, right? And allows for its customers to build highly and exceedingly customized solutions based on either their internal needs or their client needs. But you can see here some of our key industry verticals: retail, FinServ, utilities, manufacturing. But at the same time, as these are some of our kind of primary previous experience when it comes to delivering customized cloud solutions, we also believe that the data is a little bit universal, right? Subject matter expertise and industry expertise is excellent, but a lot of the times we find ourselves partnering very closely when it comes to delivering data-oriented solutions with our customers because our customers know their business best. And we stick to the data and partner and consult with our customers very specifically around the data itself. If you've ever gone to an AWS Summit or AWS reInvent or even heard a talk from any AWS solutions architect or engineer, you know that AWS services are constantly going through enhancements, feature increases, upgrades, etc. And it's pretty difficult to be on top of everything that these different AWS services have to offer. these are kind of our core competencies when it comes to AWS services and the services that we keep up to speed on from a 24/7 constant upgrade capacity, right? We spend a lot of time in the training lab with our architects and engineers, making sure that we're up to speed on every new service, every new feature, every new enhancement that these different services on AWS have to offer. And we work really closely with the AWS partner team and with the product teams, the different teams at AWS who are developing these different services to make sure that our engineers are kind of up to date with the latest and greatest when it comes to what AWS has to offer. So if any of your tech stack incorporates different AWS services and you're interested in learning a little bit more about kind of what the realm of the possible is when it comes to those services themselves and what's new and what is AWS pushing forward on and investing in, we'd be happy to talk to you about kind of what we're learning even, right? And where we're investing and what services we think are making the greatest strides when it comes to the market competition. And then when it comes to our services and solutions, just to give you a little bit of background, the primary areas here we're talking about is absolutely the data engineering, analytics, and AI teams. That's why we're all here today, right? But wanted to touch on some of the specific areas that we kind of bundle our solutions under, whether that's building analytics applications or adding analytics services onto existing homegrown and custom built applications, building out data platforms, helping you understand what does a cloud native data platform look like, how is it architected, how is performance enhanced and utilized to the greatest capacity that AWS has to offer, building more intelligent applications from the ground up, from the code base up, and then of course, how do we incorporate DevOps, DevSecOps, and manage a 24/7 availability of either code deployment, code delivery, or data delivery through those pipelines. Those are all areas of where our customers are currently and continue to seek out our expertise and services. And we'd love to talk to you about any and all of those areas, which is why we're offering you free consulting, right? So anybody who's attending the webinar today, feel free to reach out to me. I'll be reaching out to you. We want to offer you 50 hours of free consulting work complimentary to attending today. We're grateful that you all made the time to come and learn a little bit from us and learn with us and ask questions of my team and our team. So I'll be reaching out here, but if you have specific topics that you'd like to talk to architects or engineers or developers when it comes to AWS topics, even if it's not necessarily the topic that's being covered today, we'd love to help you out and we'd love to talk about it. And just to give you a sense so you know that, hey, they're not just an advanced partner who's saying there's an advanced partner. These are some of our previous clientele. There's a lot more than these 20 logos on our rap sheet, right? But we service clients across the globe and across the nation, whether from an enterprise perspective like GE, or all the way down to some of the accounts you're going to be hearing about today, which are more around the SMB startup world, right? So we'd love to talk to you more about kind of what challenges you're seeing, even if it's just for a conversation, right? I'd love to talk to you more. So here's a little bit of info about me. I'm grateful for you guys all allowing me to ramble in your ears before we get to the good stuff, right? But feel free to shoot me a text, give me a call, send me an email, and we're grateful for all of you being here. But at this moment, I want to go ahead and stop sharing my screen, get to the good stuff, and Shubham, if you want to take over and grab the mic, I hope you all enjoy today's content.
Thank you, John, for providing us with such a wonderful session. Hello, everyone. My name is Shubham, and I have been conducting market research for last 10 years. And I have been seeing the market, all the ups and downs, all the changes that are happening in every day to day. You know, we all have seen how market is changing from the AI world to the background world where nothing was there. So let me take you through an example. Imagine our first mobile, what we used. That was a leader, but now we cannot see its name. Do you know why? The only reason, he was resisting to the new technology. Now let me take you to one another example. There's a market leader in social media, which used all the new technologies. Whatever it came, he made sure that technology is implemented in that. For example, I'll tell you, AI, how it is using AI. It's using AI in two different things. First, it's showing the customers what it wants. And second, it's using for the advertisements to show the exact customers. So it's using the AI case. AI is taking the complete seats. So let me take you to some of the business use cases where AI can be used. So this is the most important thing. Every day we see AI in our world. We listen AI, but we think we should use it or not. Believe me, this is the next thing coming. If you want to use it, you use it, you'll be out of the way ahead of the competition. If not, it's the time to think. So let me go through the retail. How can retail use AI? And we have built around a product. So what can it do? For example, we know we take so much effort to build a product. It takes so much time. But as soon as we come with a product, maybe a t-shirt, maybe a pant, maybe a shoes, but other vendors start selling it. We lose our whole research. We did 1 year research and everything, but they start generating the money. What you can do, just scan your product. You'll be knowing who all are selling the same product. The AI will do it all. You just have to sit and see. The next case is your own e-commerce. We all know how all big brands have started, making a loyal audience. They want their audience to be on their platform, because once audience are in your platform, you can sell, upsell, cross sell. You can analyze their pattern, their behavior. You can sell them what they want and what you can sell. So the customers scan your website, scan the products, come to e-commerce. You can maybe a website, maybe a application, anything you want. The next thing is, you can test run your products. That this product should come to the market or it should not come to the market. Just do exclusive biddings, maybe ₹1, $1, maybe €1, anything. You can start it and you can see what is the best price for the market fit. The next thing is supply demand calculation. You can know where your product is. Is it available in the market? Is it not available in the market? Or it's someone is just black marketing it. You can have it all. Another is, we all know how much important is hoardings. We have to put our hoardings for the branding, but there is no pathway decided. What after the hoarding? Only branding. But we can decide a complete workflow for the hoarding. What we can do is scan it, get 10% discount, redirect it to anywhere, any e-commerce, your own e-commerce, any website, anywhere. The customer has a workflow. You can design a flow of the customer after that where he can go. Scan and find. Now there's a new trend. You find your products. If I'm liking this purse, scan, find. Now let me come to the healthcare sector. We all know we suffered in healthcare. In Corona, COVID, we see how much we suffered in COVID-19. And healthcare sector was a place where it was the least technology was used. But believe me, healthcare can see wonders. AI has the capability to change the complete AI. For example, predictive analysis. AI can take the new direction of the predictive analysis. Healthcare can improve the patient qualities, patient, what diseases can come, what allergies he has, all these things AI can do. Next is applications. There are multiple applications. You can do nursing, fraud detection, drug development, n number of things. Healthcare is the most place where I see the technology is going to be the next player. The next come is insurance. We all know insurance is the major part of our day-to-day life, and how insurance companies are struggling these days with so many challenges they are facing with the new technology. Some players have already started using AI, but we tend, where can we use AI? There are workflows that this paper comes in, after that this step needs to be done, this step, but it takes a lot of manual works in the insurance sector. But once the paper is scanned from one point to the end point, workflow will be in from hours to minutes. It's just a piece of cake. You can do better scan, modern storage, improve productivity. Overall, your cost will be less, clients will be happy, you will grow. Next is claims management. We all know how we struggle to manage the claims. We see so many frauds out there, and some of the innocent claims are also rejected. So what AI does, it scans the reports, all the results, and tell you the results. And believe me, AI has 95 to 96% accuracy. And with the time being, it's increasing. And at a point, we see 99.9. It's all on your data. It will take some time, but we can see that accuracy. Next is technology consulting companies. We all know there are so many technology consulting companies out there. We need AI for them also. Where, let me take you an instance for an internet service provider company who is providing internet, who is giving websites to build. So web scraping. Suppose a person is building a website, had put up material which is not allowed in US or maybe Australia, maybe Europe. AI can go and crawl the website and find this stuff should not be there on the website, and it automatically bans the source data. So you don't have to manually go and check every day, every point of time. AI does it all for you. That was all from my side. My name is Shubham. You can contact me, you can ping me, and as a complimentary offer, we are giving 50 hours of free business consulting where I will sit on, John will sit on, Nitin will help you guide what all the things pinpointing to industry needs, how can we help you to implement maybe this product, maybe any other implementation of AI, AWS, anything you want. Thank you all. Handing it over to Nitin.
Hey, thank you, Shubham. Uh, my name is Nitin Das, and I'll be sharing all the technical aspects and how to arrive at the solutions for all the use cases which Shubham just shared. Oh, I hope you all can see my screen. Yeah, so Shubham just showed us different use cases in AI, ML, and DL, right? So I would say for the primary missing piece of the puzzle would be a computer vision challenge, for which AWS, offers with a AI services called Amazon Recognition as well as Textract. It's a fully managed service. It extracts information from images, videos, and builds computer vision apps, models faster, less costly, and customizable to our business needs. So let me also walk you through the agenda of what we have today. So I'll be starting with demystifying AI, ML, and DL. That means we'll have clear distinction and understanding between what is artificial intelligence, what is ML, that is machine learning, and deep learning. Why I'm doing that is for us to understand the AWS AI ML stack, which is being followed by the next topic. We need to know those basics so we can see the layers where AWS operates on. And next, coming to deep learning neural networks and training a neural network, I'll be touching a very few slides on that. It's just a visual contemplation for you guys to understand what's running in the behind the hood or in AWS backend. Post that, we have our use case today for one of our client. We have our solutions, results, and architecture, which will be going live and showcasing you the architectural design and the flow. Post that, we'll have a demo. We'll have a live demo showing how the recognition and extract works. And then we'll also get into the low-level architecture of the same use case. And after that, we'll also look into the SAM module, that is serverless application module. And we'll see how the whole thing is orchestrated using Lambda functions and API. Hope you guys have the whole agenda for today. Let's get started. Demystifying AI, ML, and DL. So that means like deep learning is a subset of machine learning, as you can see from the image, and ML is a technique for realizing AI. So when I say artificial intelligence, it's a technique which enables machines to mimic human behavior. So that's in the top layer. But under the hood, again, there are some machine learning algorithms which runs. So that will be nothing but a statistical methods like supervised learning, unsupervised learning, and all that. Maybe the budding machine learning engineers or data scientists will be already aware of these things. But one thing they would miss out when they start the journey of learning is the deep learning. So which I'll try to make some justice on that. So subset of ML, which makes the computation of multi-layer neural network, is what we're going to see next. And for that, I'm so sorry, and we'll also see the stack, how it's layered. So the AI services, what we have on the top layer, you can see the one which we are going to target is Amazon Recognition and Amazon Textract, so which we primarily used for our particular use case. But other than that, we also have specialized services. It's particularly focused on certain industries, like in, for example, fraud detection in banking sector or forecasting, uh, uh, sales and all that. Kendra is a search AI search tool, And we also have Amazon Health Lake, which Shubham gave lots of insights. So here if I can talk about that, there'll be another webinar. We also have one. If you can check our website, you can click on get more insights on how healthcare helps us build many applications on that and analytics as well. I'll also touch the ML layer. So Amazon SageMaker. So SageMaker is the table topper in this particular AWS stack, because you get to prepare the data, train the data, do feature selections, train model, deploy model, work on a lot of things. It's similar to a Jupyter notebook, what you have, but instead of local, we have it on cloud. And you have all the GPUs, you have tons of selections. I think even the TPU is available as of now. And they've also advanced in low code, no code, that is SageMaker Canvas and Data Wrangler, which helps you. It also automates what SageMaker is already doing. Like, for example, feature selections all comes in a click of a button. To go to the last layer, before going there, I'll give you some example on how this deep learning network works. So then we will have a better understanding of the last layer. So let's start with neural networks, a series of algorithms that endeavors to recognize underlying relationships in a set of data through a process that mimics the way the human brain works. So why I say that is, when I say artificial intelligence, where is this all coming? It's same as our brain. How we work is the same way the machine works. In this case, you can see in my slide, there's a picture of a brain with the start of an eye. So in our case, for a machine, the eye is nothing but the images what we send in, and the brain is nothing but the neural networks what we create in between, and the output is whatever sensory systems we're going to give it out. So this is a visual representation of input, sensing device, interpreting device, and also the output. Okay, so let me take a classification example. So perception in neural networks. Neural networks pass an input, like an image, through multiple layers of digital neurons. When I say digital neurons, you can see these small dots, circle dots in different colors, right? These would be similar to the neurons which is there in your brain as well. In our case, we'll use TensorFlow and Keras to build this network. And usually it starts with the input layer and an output layer. And in between, we'll have hidden layers that can raise from 2 to even millions and billions of neurons. You guys must have heard about ChatGPT, and you guys are already working on adapting to that. So that is the same technology where it has almost billions of neurons in between these two. And if billions of neurons are there, you can see the output of every neuron is connected to the other hidden layers. So these are the parameters. When I say parameters, there are weights and biases. Then these parameters can go up to trillions of parameters, because if there are billions of neurons and each neuron giving its own weights and biases, it adds to the parameters. And the ChatGPT is trained on such trillions of parameters. That's why you're able to get easy results. Before I go to the next slide, I would also love to show you some hacks in learning this skill. So there's something called as TensorFlow Playground. So what I just showed you in this visual, you can do the same. If in case you don't have access to GPUs or a notebook and all, and if you still would love to look into how this neural network works and all, you can just use this. So you see the input layer which I have in the start, and hidden layers what I can keep on adding, and also see the output layer. We have different types of data here, and we can just start the training of the neural network. You can see how the data changes, how it gets trained in every box. On the top, you see all the hyperparameter tunings. Same way how a human has to be trained, there will be some learning rate. Every human's learning rate is different. So activation function again. So it goes deep, guys. Yeah, I would want you guys to take a deeper look on how these networks work. You can relate much to a actual human. Okay, so saying that, let me stop. So this is how your final output should look. And when you saw the same neural network, steps involved. How do you train this neural network? We start with data labeling. Like, we have folders of images saying this is a watch, this is an orange, this is an apple. Feed it to the machine. We'll have expert knowledge guy who labels this training data, and we have different frameworks. And those frameworks to work upon, we need lots of GPUs. And those GPUs again have to be retrained, modeled, and get the precision tested. Then we can let it for inference. You can see in this image how a cargo image is being labeled as cargo and cruiser, and etc. So now I think you'll be able to understand the last layer, that is frameworks and infrastructure of ML. So as I showed you, the PyTorch, TensorFlow, MXNet, GPUs can be built from scratch because we can create the infrastructure, we design the whole neural networks, everything can be done. This we choose if at all the top layers are not helping us to work on some specific domains and you want it to be done very specific to your industry, then we can go for this last layer. Let me quickly showcase our use case. So Impresari, which you saw in the case clients, what we had Shubham shared, it was a luxury watch rental company. And the main issue was they had a lot of paper catalogs like magazines. You can see the watch images. They dealt with companies like Rolex, Patek Philippe, and Omega, and etc. All luxurious brand watches. So the problem here was there are a lot of magazines. So what you can see in the center of my screen, this was a cutout of a picture from a magazine, and we also see the transition how it goes into a website. And also we see the data, how this data from a brochure is being extracted and even placed properly in a key value pair. Okay, so the challenge, as I already told you, to eradicate the use of physical catalogs and launch of digital database and identification solution for luxury products. And delivery of business outcome was we used a lot of broad AWS services like recognition and text track for data extraction, and quick site for developing product analytics, and ability to fail fast is like the client had more different types of layouts, so we had to do small POCs, get his attention on different layouts, get the perfection done, and small POCs were then first, to be honest, we started with the server approach first and it didn't work out because then we went to a serverless approach. Finally we ended up doing a SAM module. The solution, again, machine learning, using machine learning image-based recognition, we all did this. And the result was 15x faster in discovery through automation, and 100% human effort automation was also done. So before I get into the actual flow or the demo, I'll show you the high-level architecture where we have pictures or watch catalogs from a magazine or a brochure falls into the S3 bucket. We have event trigger from Lambda function, which sends it over to the text tract or recognition, gets the output from that and posts it back to S3. Now let me also log into the AWS account and have this immersion day little bit interesting. So this is the AWS console. This is how it looks. If you guys don't have one, you can create one on your own with using your debit card or something. It won't cost much. There'll be a 1 year of free tier which you can work on. And post that will be charging. So we have all these other services for compute, security, container storage, database. You can see all this different database. But under machine learning, again, the table topper was SageMaker. We are going to use recognition and text track for this lab purpose. So let's try a demo how recognition works. So here on the screen, there's a default picture, which you can see the person is already detected, even a skateboarder is detected, and car is being detected. So this is something called as object detection, not the classification which I showed you in the prior to the neural networks. So once you add an image, it identifies all possible objects within, again, it should be trained in the past, and we get the response called with the labels response. There are two different outputs here in the sense you need to understand the main two outputs is the labeling and the bounding boxes what you get. Let me show that all as well. It says person and the bounding box of the person. So when I say bounding box, it's the dimension on the picture of the two-dimensional image what you send, like the coordinates of x and y axis, so that you can use that to crop, edit, do whatever your use case wants to. Let me add a stock photo from my system. This even you guys can try it out if you have your own account. We can see how it's identifying a box, a plant, a laptop, and pen. And some images can't be recognized here because of the low quality of the image or subject areas. In that case, again, it's not 100%. As Shubham said, it's around 90%. There's also work around there. Now let me also upload a watch image, which we have done. So from here, you will be able to understand how the flow starts. So once the image is fallen into S3 bucket and the Lambda function picks it up, sends it to recognition, this is how under the hood it happens. So it sends to an API call. We get the output in response. See, the main advantage was it was able to detect the wristwatches here. It's 4 wristwatches here. So I got that information, and we have bounding boxes, 4 bounding boxes for 4 different watches. So that's it for recognition. Let me quickly get into extract, and this is where a lot of use cases with Shubham just said about OCRing, converting your forms to formless and paperless works can be done. Again, AWS also as a example pay stub here. You can see how the forms fields have been raw text. Firstly, it can detect all the text over a document from line 1 to the line last. Again, the forms, it is able to detect the fields, the headings, the tables as well. And in queries, in case you can also do a direct query or as a cross pay if it is very legit and also very structured format you have in the form. It's very easy to do that. Let me show you another example for health insurance or a loan application would be good, I guess. And you see there are a lot of fields, and for a person to type manually and do this even with the only OCR, it's going to take a lot of time. And we have raw text, we have forms for every field. We can do a check whether it's clicked or not. Automation can be done in all levels here. So let me also choose our own use case document here, and I'll show you a example for that. So what we get to choose, what do I want from this image? Is it a form, table, and query? I'll just add these, and the query will be like, what shall I add? It'll be like, okay, which is the dominant color in these watches? And this query and apply, and let me start pay call. Let's wait for the results. Then let me check back for. So this is how we simultaneously actually send the image first to recognition, get it back, and we send it to extract as well. While it's loading, yeah, it's already loaded. We have all the detection of the words and the specifications of the watches here. Forms are not available, so it didn't detect anything. And tables, even though there are no specific tables or lines, imaginary lines in between, you can see how extract is still able to pick up uh, the format or structured form. This is what I'm talking about, the quality of the papers, what we have. If we start designing there, then the flow will be seamless. And queries, see, it's able to even do an NLP in the background and give us which was the dominant color in these watches. Saying that, let me quickly different use cases which recognition and extract can handle. Firstly, as the labels, I told you, it was able to detect the labels. Okay, but until now, I guess you guys would have had understanding of how this AML all worked.
Quick question, Nathan.
Yep.
So I was wondering, or like I understand that AWS recognition model is able to detect the wristwatch within the picture by giving the coordinates, but you
Yep.
said it's a Rolex watch, right? So can the recognition model also like recognize between a Rolex or like some other brand?
Oh, yeah, got it. Actually, what you're talking about is image recognition. So that's another aspect. The what I just showed you was object detection. So in that case, yeah, that's very much possible. That's a totally different use case, but we add that use case for a customer end perspective. So if a customer wants to scan his watch and see or do a search image with that index, he can always go to this custom labels we have from recognition itself, where you can train your own model. Like that's again so managed by AWS itself. Create a project, create data sets. For that, you'll need individual pictures of each watch in a high quality. The quality of the images matter a lot to train the neural network. Then label the images. So like maybe take an example, 10 Rolex watches, you have 10 images of different models and name them. And per particular model, at least we need 10 to 15 watches and different angles or to identify it's all depends on data documentation how it works. And for Patek, again 10 more images. We do that and train the model, evaluate, and you can use the model. That's when you can also recognize it. Then the system will be able to tell whether this is a Rolex watch, even the model. It's way how we label it. It can differentiate between two. That's how it goes. That's a good question. Thanks for asking. And that's also in my next slides. So that's what recognition can also do. No, it can detect text and images. It can detect faces, celebrity recognition, real-time video analysis as well. So these are the labels, inbuilt labels, which recognition can give us with a confidence score of percentage. And then we also have other parts like, it can detect damage detection, inventory management, document classification, identify logos, products, machines. So these can be used in manufacturing plants or retails, different stores. Even in insurance automation, it can detect, if what is the degree of damage is done to cars. So based on that, we can run analytics and give a quote on the insurance, and many things can be done. So metadata extraction and enrichment, we start using the extract for that. And the industries all I think it's be covering is finance, insurance, real estate, accounting, tax, medical, legal industries. A lot of forms are there that can be converted as well. Business management, education, schoolings, and all these applications can be automated. That's how the world is going around. And what are the challenges? So if you see, you have a lot of admission forms and all has to be updated. So you can't have an individual data entry person, doing that for thousands or 2000s. It's a workload too much for them, and also it's a linear task which we should stop doing and think something deeper than that. So that's expensive, error prone also, and time consuming. Extract can again extract tables, text, and forms. As I told you, these are the API which I use, and we get the data in the form of paragraph, lines, and words. And for to implement this, what we have is the input, uploaded document images such as tax forms or credits falls into the S3 bucket, and from S3, Lambda will be triggered to initiate this analysis. From text track, we get those keywords, key value pairs, and output can be performed. But in our case, we had to, use NLP because there had to be some changes to be made, enrichments and analysis has to be made. So we had to use NLP in between. Okay, let me come to the low level architecture here. So this is where we'll start the demo of end-to-end flow. We can see how at start step one, how the images fall into the S3 bucket. For this, we have used serverless S3 image upload, which I'll be also showing few cloud formation templates if time permits, and also the flow after that. And the image falls in. I am repeating this again for you to understand the flow. Lambda triggers both recognition text track, gets the output, puts it out, and then you can either run a Lambda or a glue crawler, put it into RDS or S3, again get it back to QuickSight. So once we have the data, we can do many such analytics. Let me start with the live demo, for which let me get into the S3 buckets. Let me find the front-end index page what we have, and this is also from a template, CloudFormation template. And we did some adjustments to this, like in terms of look and feel for a person based on the client, and also other API calls. I will show you shortly how that works. So we get to choose this Rolex watches. So this is a front-end application or a website. It's a serverless application again, where we can use this to upload images to S3. So I've selected Rolex now. Let me add like few images. I choose 5 files here. Let me upload quickly. This flow is just to upload the images to the S3 so that we have it under AWS cloud environment, so that we can trigger and play around with the images what we want. So we get the success notification there. And let me also choose Patek here. So it has a few more watches. It's a different brand. So if we think from what to say, from a person who's uploading these pictures, he might have thousands of images, and AWS Lambda can scale out, and even multiple images or multiple web apps can be used at the same time because of its throttling capacities. And let me verify by going into the input bucket and check if the image has landed in S3, and that I'll have to go into the S3 bucket, and this is where I'll show you the different APIs what we use under Rolex. I think around you guys can see for now the two images. One image is loaded. Slowly we get other images as well. we got all the images see in the flow. And let me also show you this page source, and I'll show you how the backend worked. We created multiple APIs for multiple buckets. So but the CloudFormation template came with a single API. The edit what we did was adding we created another API calls from API gateway. Again, it had to be a version 2 API when you're creating, not from stock, so that the image can be transferred, and different APIs feeds to different buckets here. So we have this watch here. Let me again go through the flow. Now is what I'm going to show you, the triggering part. Let me choose a bucket itself, go to the properties and see how this trigger happens. Once all these images fall, we have different event notifications which triggers the Lambda function. Let me also open up the Lambda function. So once the picture falls into S3 bucket, we have a Lambda function that gets triggered, and the Lambda function consists of just a pillow. It's a package, it's layers, it's a different concept. I can touch base on that later. But that's a package in Python used to crop, edit images, and do all that. So we can also see the logs if the code has successfully triggered and worked. And this is the code where we differentiate the image text from different APIs. We get the response, we do all our NLP within this, and give the output to an S3 bucket. So after this is triggered, let me see. Yes, it's been triggered at this time. And let me see the result. So it was able to fetch the bracelets integrate. All these were dictionaries which we gave, which we required to check. So how do I check right now? Let me just quickly show into Athena. Athena is a crawl. After you crawl it, you can view the data within this particular UI. Take the limit 400 at least watches so that you'll have an understanding where enrichment can be added for this. So we see reference means the model number of all these watches like Rolex, Patek, and different. Every watch comes with its own model numbers, or in some cases name, and its product description. You can see the dial color, movement, band type, band material, what you can see some empty. So these empty fields or null fields can always be enriched and added with the second Lambda function. So here we have the partitioned brand name and case materials. Let me show how analytics can be performed using QuickSight from here. So this is how you cover end to end, how image from a paper, it becomes a valuable insight when it comes to the cloud. So I have a existing dashboard which we have. Let me see if it's still. So here you can visualize a lot. QuickSight again, I did not say about that. It's like equivalent to Power BI, and we have a lot of new graphs as well to work on. We do also have such capabilities in our in-house. So dial types, word count. So you can see the most frequent dial tones within the inventory. So we can have an inventory analytics within, and we can also see the inventory stock, which watches more counts, Rolex Photography, and we also have KPI. We can see the stock sales, is it going up or down? And this is a pivot table which I have just had for cross-checking with the admin. And then we also can have this bezel distribution. We can see which particular trend or kind of bezel is fast moving, and what is it percentage in within the inventory. So case size, again, different case sizes. We can it's all for the inventory purposes. And when it comes to analytics, again, we can see brand wise analytics, and whether it's how many self-winding movements are there for this particular brand, and how is it moving, and all that. So this is the whole complete flow we just saw from the start to end, how it works. And we started with the watch, which falls into S3 bucket, just like a paper image, and we see how the data comes out by using multiple AI services. And just a short, I have some time, I guess. So serverless application, we for this serverless application, if not this, we would have actually gone for EC2 server standing website, which has to temporarily store the images, and it has to be running all the time. And then from that image, it has to go just to sit in the S3 bucket. So instead of spinning up a server to do that, we went serverless, adding just with the event notification, and we had good CloudFormation templates for that, and nice documentation from AWS to work on those. And disadvantages using a traditional server than serverless is obviously the CPU time will be more, and network input output buffering will be there. And also if there is traffic during certain times, it might not allow the images to pass through, and it can cause a lot of damage. But the same thing doesn't happen in Lambda function because it scales out. We can also give application load balance. There are different ways to challenge this, but we thought this is the best way for just uploading the images into S3. But that itself had so many different concepts. That's why I wanted to show this. So it uses signed URL. This also it uses another Lambda function where we can choose which bucket the images has to follow with based on the API. And this is how once the SAM module completes, it modules the whole packages and then gets us into this AWS system. So for this, you need to install CLI. That's SAM CLI is something different from AWS CLI. So you need to do that as well. And there'll be different commands to deploy as well. And this is the example of the URL. I just copied the URL and showed you the web page. This is the stock one. And lastly, the Lambda function, which helped us to do all these orchestration. So if you consider Lambda as a logic and the database and S3 storage as a state, and the communication between them could be the APIs, Kinesis, or SNS notifications or queue systems. So I hope you guys have enjoyed this technical aspect flow from end to end. So any questions can be taken from now, and over to you, Sanjana.
Thanks, Nitin, for walking us through a great demo and informational session. That was a lot of information, but you did a great job explaining it all. And so, like Nitin said before, it's time to answer some questions from our participants. So team, are you guys ready?
Yes,
Yes.
we do. Yeah.
Great. So we'll try our best to answer as many questions as possible, and we can also provide an exclusive one-on-one session pinpointing your organization's needs. So feel free to email us with any inquiries or questions to John's email, and his email is john.aguilar@ittstar.com. I guess the first question, Shubham, you should take this. How can the legal industry use this product?
Okay. So legal industry, we all know there are lot and lots of paperwork involved. For, there are cases which are running in court for like 10 years, maybe 15 years. The judicial system is for 20 years. So people have to maintain a lot of paperwork. There are references in the legal system, we all know. What we can do, just as the case is going, we can just scan the paper, put into the AWS environment. Now AI will tell you what is the probability of it, how to take it forward. And there are so many ways. You can take some reference, legal industries, maybe you can do e-discovery call, getting a call recorded, using it into AI model. There are n number of ways. And the person who has asked, we can sit on, we can give him end to end, like how can we help, completely help. That's it.
Great, thanks, Shubham. So Nitin, it looks like the next one's for you. How is it different from Google Lens?
Yeah, I just saw that question and I was trying myself with an image, I tried to upload. So yeah, that's a good question. So Google Lens, it's nothing totally different from what I've just showed you. The backend, the Google Lens or the Google GCP is using the same technology like deep neural networks to identify images or texts. But why is it different here? Because we are using it for our own specific use case. So if you have a Google Lens, it's going to give you the search data of different watches which is present online, which we don't want to do that. And we just need to mark it with our own application. So you can also tell me you can use Google APIs, but again, the text what comes out, it will be like the raw text what comes out of it. We will still need the Lambda functions and other compute resources to form our NLP. The natural language processing is required, or different formats can be used to organize this data, what we extract. So extraction methods seems to be the same. Hope it's clear, answer.
Great. Nitin, also the next question's for you as well. One participant is asking, what happens if the recognition is not able to detect the watch in a specific image? So like, what are the alternatives to it? And can we retrain the recognition model?
Oh, okay. That's a twofold question. Yeah. So in this case, if a watch is not being able to, identified by the recognition, what we can do is search for the confidence score. And even if it's mismatching, so if the confidence score goes below 85, in my case, I've done that, so it's not able to. That means the picture is not, clear enough, or the watch is not good. So that is why you're not able to detect using the lake. But we try the best for the image to, be and out of good clarity so that the detection can be done. So if it's not happening in that case, we'll either put it back to a different S3 bucket, saying that this is where the concept of human in the loop comes in. AI cannot work on its own forever, so there has to be a human in the loop who moderates, trains it every now and then. It's more of a reinforcement learning, what I can say, based on rewards and punishments. So like that's for a totally different concept, like self-driving cars and all. But here also the similar aspects will be used. And it the next same question I had, can you retrain the recognition? No, you can't, because it's a model deployed from AWS themselves. They have trained with the state of the art servers, CPUs, GPUs, and all that. So what we can do is, if you have a specific use case that's not being able to detect from recognition, as I showed you the AWS layer in the beginning, we can always fall back to even SageMaker. You can create something from scratch, or use its inbuilt image classification algorithms, train it in SageMaker, or even get to a lower level of having EC2 instance, huge EC2 instance with GPU AMIs, deep learning AMIs, and you can start from there as well. In that case, retraining and all this is possible, but AI services, we need to wait for the updates from recognitions, FAQs, or first note.
Nitin, there's also a follow-up regarding that. So how might image recognition enhance customer interactions and overall satisfaction with their offerings?
I would say, like, it's totally depends on the use case. How do you want the customers' interactions to be? So you want to make them more interactive, get them all done. So you can do a scanner app where you can give them reward points, or uh, scan the image, see the similar products from there. You can have more interaction with the customer based on their needs. So you scan the watch, you can give you similar color, different brands, and in that case, it's totally customers' experience can be enhanced in that way. And satisfaction with our offerings, I think the only satisfaction here would be like complete automation from a human process. So you have like a person doing a data entry from all those images. He has to separately crop the image, individually type all these key points like the dial color and all into an entry point, where how much can they do in an hour? So this lambda recognition can run in seconds. You guys saw the processing speed, right? It was instant, almost instant. So in that case, a lot of satisfaction will be there in terms of reducing human labor or manpower.
Great. And then could you also elaborate on any ethical or social considerations associated with this topic?
So when you say the ethical part, yeah, even I'm doing a lot of R&D on that, because see, whatever you train the model to, it's gonna do what you're gonna give the training data. But something what is missing is a consciousness. So although ChatGPT is they do say there is consciousness levels, but I don't think so. It's the exact consciousness what we receive as a human is. So that's what makes us different from an AI. That's the only thing. I'm still seeing if AI can have that consciousness, and how can that be trained. And large language model is getting there, but I'm still figuring it out myself.
Great. Also, one more question. Are there authentication mechanisms or access controls to prevent unauthorized use of image recognition services?
Yeah, definitely. See, if you see the front end application, what we had, it had a login. So there is authorization front end. So that has to be applied separately based on the user needs. Suppose if they want MFA, and all these can be added. So it's already protected in cloud, because we come under the VPC cloud. Everything is under VPN, and we can have a private subnet, public subnet, so that the API calls don't go over the internet, and it's restricted to only the users. And but when it comes to customer, they still have to have the internet access, so their database is in separate place. So that is completely well architectured under AWS, that can all be provided.
Great. Thanks, Nathan. Shubham, we have a business related question for you.
Yes, Sanjana, tell please.
So can this technology be used for different healthcare specialties?
Yes, why not? So let me tell you a use case about it. Let us take example of a radiology. So what happens in radiology? Suppose in X-ray, if you go to a doctor, you do X-ray. But what happens that doctors needs very much years of experience to understand the level of fractures. For instance, I have a knee injury. So the more the doctor is trained, then only he can tell me in precision that you'll be need 6 weeks of rest, 2 months of plastering and all those. But AI, as we train the model, it can tell us immediately. Like it will be helping the doctor. We'll take all the models. It will tell, okay, you need 4 weeks of bed rest and you don't have a much fracture. With the help of a doctor, it can take a complete different way. Like it can go up to 99% accuracy with time being. So healthcare, every sector, it has application. Just depends where are you using it. We have to precise it. We have to pinpoint it, and you can get the solution.
Okay, great,
Oh,
great, Shubham. Thank you.
thank you, Sanjana.
Nitin, I think you should answer this one. Is there a limit for all the labels recognition can detect?
Yeah, okay. So with what I've showed you in the labels, the count of the labels for recognition can give you is around it comes around 3000 now, and 3000 labels can be detected, and alias is around 1.5 times of that. And but bounding boxes, when I say, see, the wristwatch, when it identified, it was able to give the bounding box as well, but that limits up to just 252. So 250 images can be detected with the bounding box, but still around 3000 labels like sceneries, lakes, parks, or bicycle, all these can still be detected as a label, so you can make use of it as well. So 3000 is the labeling limit, and as of now, and they keep updating. And bounding box limit is around 252, and it's all available online. You can download and check. It's a threshold or limits of the services.
Yeah, thanks, Nitin, and thanks, Shubham, for answering the questions. As John mentioned before, all our participants are eligible for 50 hours of free IT consulting, and you can send an inquiry to John, who will be able to help you further as per your business needs and requirements. Also, this solution is also available on AWS Marketplace. And finally, feel free to reach out to John, like I said before, our sales manager at john.aguilar@ittstar.com. He'd be happy to help you with any needs or concerns or inquiries that you might have. I would like to thank everyone for being an active part of our session. This is Sanjana from ITTStar signing off. Thank you.